Did you know that the human body contains over 30 trillion cells? I'll say that again. Over 30 trillion cells. That's a big number. And there's a reason for this. There are advantages of having many cells, in particular many small cells, instead of one really big cell. One advantage is division of labor. If you have many cells, cells can specialize, and those specialized cells will perform functions more efficiently and effectively. It's like you would probably perform better if you could study for a math test one week and then a science test the next week, instead of having both math and science on the same day. There's interdependence of cells, so cells depend on each other in order to operate, but if you have many cells, if one cell in an organism dies, it's not going to kill the entire organism. There's still many cells to go around doing their jobs. And finally, a really important one which we're going to focus on is size. Size, meaning the smaller the cell, the better it is for the efficient exchange of materials. So let's take a look at this smaller cell is better. If, for example, oxygen wants to travel from outside the cell all the way to the middle of the cell, in a small cell it won't have much distance to cover, so that traveling time would be reduced. In a big cell, particles need to travel further, therefore the rate of diffusion is slower, therefore it's just a less efficient process. And in a bigger cell, it's not just the distance covered that is the issue. The bigger the cell, meaning the bigger volume, V, the more particles in it that are going to need to be transported. And we know those particles must cross the outside of the cell membrane, which we can consider as the surface area of the cell, or A. And the thing is, for any object that's increasing in size, its volume is going to increase at a faster rate than its surface area. So for example, if a cube grows from 1 to 10, its volume is going to increase by 1,000 times, whereas its surface area increases by only 100 times. So the volume is increasing 10 times faster in that case than its surface area. It's like if you had 10 times as many cars on the road, those cars are going to be traveling at a slower pace, and there's going to be a lot more traffic jams. For a cell, that means there's many more particles that need to go in and out of the cell, but not enough membrane to process all that incoming and outgoing traffic. So when we look at size of the cell, what we're really looking at is the ratio, or comparing the surface area to the volume of the cell. A larger surface area to volume ratio means that materials can be transported more efficiently. Now, cells come in all different kinds of shapes, but again, the key is you want small cells, because small cells mean that the surface area to volume ratio is big, and that's a good thing. That means materials can be transported efficiently. If this was the regular school year, we would go through all these different shapes and go through all the different formulas to see how we can derive them. But really all you need to know is in the red bar. If you want, you can prove this for yourself. You can take these surface area formulas and then divide them by the volume formulas, and that would be your surface area to volume ratio. Surface area to volume ratio is just the surface area divided by the volume. We don't really have that opportunity being we're doing this online, so it's just enough to, in your notes, list the different types, the different ratios for the different types of shapes. And here are a couple of real-life examples on surface area to volume ratio. So you have microvilli in the digestive tract, that's the picture on the left, and root hairs in plants, that's the picture on the bottom. They need to absorb a lot of nutrients from their surroundings. That's their job. So look at this shape. They're long and thin. That long and thin shape means you have a large surface area towards a smaller amount of volume. So the long and thin shape means a big surface area to volume, because these are cells that specialize in transport. So they need that large membrane to pass through all the materials going in and out of the cell. So that's it for this presentation. I will give you a worksheet on this section to work on for today as well.